Hello and welcome to the Answer Series Natural Sciences videos based on our study guides. In this video, we will look at two ways of separating pure substances. Remember from our previous video that a pure substance is matter that has a constant composition and cannot be broken down by any physical means. Elements and compounds are pure substances, and molecules make up both elements or compounds. A pure substance has a constant composition. In other words, all the particles in that substance are the same. In an element, the same atom is repeated. In a compound, the same molecule is repeated. In other words, the same ratio of atoms is repeated. Pure substances cannot be separated by physical means because the atoms have chemically bonded. Physical means of separating substances include hand sorting, sieving, filtration, magnetic separation, distillation, evaporation, and chromatography. Some pure substances can be broken down by chemical means. Chemical means of separating substances include using electrical or heat energy to break the strong chemical bonds between the atoms. Because elements consist of only one kind of atom or molecule, they cannot be broken down by physical or chemical means. However, compounds can be broken down by chemical means. We call these types of reactions decomposition reactions. A decomposition reaction is a chemical reaction where a compound breaks down into simpler compounds or elements. We will look at two ways to chemically break down a compound, first using electricity and then using heat. A decomposition reaction that uses electricity to break the chemical bonds in a compound is called electrolysis. Electrolysis involves a solution called the electrolyte that can conduct electricity, two carbon electrodes that are connected to the terminals of a battery. The one electrode, the positive, is connected to the positive terminal of the battery. The other electrode, the negative one, is connected to the negative terminal of the battery. And lastly, it also requires an electric current that provides energy for the chemical reaction to take place. So for the first investigation on electrolysis, we will use copper chloride as our compound. It is composed of copper and chlorine that reacted chemically to form the compound copper chloride. Remember, we said that the properties of a compound will be different from the properties of the individual elements that make up the compound. And this is also true for copper chloride. On its own, the element copper is a shiny, magnetic, red-brown metal, and the element chlorine is a yellow-green poisonous gas. But when these two elements chemically react and bond to form copper chloride, the properties of the compound is different to the properties of the individual elements that it is made up of. The copper chloride is a deep blue crystalline powder that is not shiny or magnetic like the copper metal was, nor is it a poisonous gas like the chlorine was. When you dissolve copper chloride crystals in water, it can be used as an electrolyte, a solution that can conduct electricity. That makes it ideally suited to the decomposition reaction, which uses electricity. For the full-scale investigation, you will need copper chloride, water, a beaker, two carbon electrodes, conducting wires, and a 9-volt battery. Because I don't have a lab or a full range of laboratory equipment, I decided to do a micro-scale version of this investigation. And this is ideal when you're conducting science on a shoestring budget. There's less mess, and it would even be a great experiment for learners to do in groups in your class. For the micro-scale version of the investigation, you will need copper chloride solution, a plastic bag and white paper, a medicine dropper, masking tape, two HB pencil leads that will act as mini electrodes. Remember that pencil lead is basically carbon, so you can use any type of pencil lead thickness. You'll also need conducting wires and batteries, and a petri dish as an optional extra. I bought the battery holder and wire kit from my local P&A. Dissolve 1 teaspoon of copper chloride in a cup of water and stir until the crystals are all dissolved. Now place the white paper inside the plastic bag to provide a crystal clear work surface where you can clearly see the reactions happening, and that makes an easy cleanup. Carefully connect each of the pencil lead electrodes to the battery you have with your conducting wires. This takes a little bit of practice if they're very, very fine, so you need to work carefully so that you don't break the pencil lead. Secure the two tiny electrodes a small distance apart by using the masking tape. Make sure that the electrodes do not touch each other whilst they're connected. Separate reactions are going to occur at each electrode. The positive electrode is called the anode, and the negative electrode is called the cathode. Make sure you leave a nice gap between the two tiny electrodes where you can now add a drop or two of the copper chloride solution so that it spreads and touches each electrode. Optionally, you can place a petri dish over the setup to try and trap any gases. So observe what happens at each electrode. When electricity flows through the copper chloride solution, it provides enough energy to break the chemical bonds between the copper and the chlorine. Copper is a metal with a positive charge, and it's attracted to the negative electrode called the cathode. You can see a red-brown layer forms on the negative electrode due to the formation of a copper precipitate. A precipitate is a solid substance that forms in a liquid solution. Chlorine has a negative charge and it's attracted to the positive electrode called the anode. You can see small gas bubbles appear around the positive electrode. These are identified as chlorine gas. You can also confirm this by lifting the petri dish and gently wafting some of the gas that has accumulated inside it towards your nose. You'll notice that it has a chlorine or bleach-like smell, the smell of a clean swimming pool, which is very characteristic of chlorine. The deep blue copper chloride solution also becomes lighter over time the longer the electrolysis continues. So from this investigation, we can conclude that a compound can be broken down into its elements using electrolysis. Now, electrolysis is one method of performing a decomposition reaction. Another method involves adding heat energy. For this investigation, we're going to use potassium permanganate, which comes in beautiful purple crystals, and you can also buy these at your local pharmacy. From its chemical formula, we can see that the compound contains oxygen, which is a gas. So we'll test for the presence of oxygen to prove that the compound is being broken down by the heat and therefore releasing the oxygen gas. To perform the investigation, you'll need potassium permanganate crystals, a Bunsen burner or gas hob, a test tube, something to hold on to your test tube so that you don't burn yourself, some cotton wool, and a wooden splint. Add a small amount of potassium permanganate to your test tube and place a bit of cotton wool at the mouth of the test tube to ensure that the oxygen gas accumulates inside the test tube rather than escaping slowly. This will make your test for oxygen much easier. Hold the test tube above the Bunsen burner or gas hob using tongs or a retort stand and clamp so that you're not burning your hands. Gently heat the test tube so that the potassium permanganate starts to melt. You'll hear the crystals crackle, pop, and fizzle as this is happening. When the potassium permanganate is heated, it decomposes partially to release oxygen, and we can test for the presence of oxygen using a glowing wooden splint. Remove the cotton wool from the mouth of the test tube, quickly light a wooden splint, and snuff it out so that it is still glowing. Hold the glowing wooden splint near the mouth of the test tube and observe what happens. Oxygen is a flammable gas. Everything burns in oxygen, and therefore the glowing splint will spontaneously reignite or relight. Now, the potassium permanganate does not decompose completely, as the heating process doesn't supply enough energy for that to happen, but we know that some form of this compound is being broken down and releasing the oxygen. So from this investigation, we can conclude that a compound can be broken down partially using heat energy. Key terminology for this video includes decomposition reaction, electrolysis, electrolyte, electrode, anode, cathode, and precipitate. Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.